In every war movie you've seen it, the radio operator hunched over a bulky device, calling in artillery strikes or reporting enemy positions. But these radios weren't just movie props. They were revolutionary technology that fundamentally changed how wars were fought. Before reliable field radios, armies communicated with runners, signal flags, or telephone wires. Orders took hours to deliver. Commanders were blind to what was happening beyond their immediate vision. Coordination between units was nearly impossible. Radio changed everything. Suddenly, a commander could talk to troops miles away. Artillery could be directed onto targets in minutes instead of hours. Aircraft could coordinate with ground forces in real time. The battlefield became connected in ways that had never been possible before. Today we're going to explore how field radios transformed warfare, the technology, the tactics, and the people who operated these critical devices under the worst possible conditions. To understand the revolution radio created, we need to understand how armies communicated before. In the First World War and earlier conflicts, battlefield communication was painfully slow and unreliable. Runners carried written messages by foot, often through enemy fire. These men had one of the most dangerous jobs in the military, running across open ground while being shot at just to deliver a piece of paper. Many never completed their missions. Signal flags and lamps allowed visual communication, but only when units could see each other. Smoke, fog, darkness, or terrain features made visual signals useless. And the enemy could see them too, compromising security. Telephone lines connected command posts, but these wires were vulnerable. Artillery fire cut them. Advancing troops ran over them. Enemy patrols deliberately destroyed them. Repair crews spent entire battles trying to keep lines functioning. Wire communication worked in static defensive positions, but failed completely in mobile warfare. As soon as troops advanced beyond their wire network, they lost contact with headquarters. Commanders were blind, unable to coordinate or respond to changing situations. The communication lag meant that by the time information reached commanders and orders returned to the front, the tactical situation had often changed completely. Units were fighting blind, making decisions without knowing what friendly forces on their flanks were doing. Radio technology existed before the war, but early military radios were massive, fragile, and unreliable. A 1930s-era radio might require a truck to transport it. Setting up required deploying antennas, connecting batteries, and warming up vacuum tubes. These early radios were essentially mobile radio stations. They could communicate over long distances, but weren't practical for frontline troops. They belonged in headquarters, not foxholes. The technology relied on vacuum tubes, glass bulbs containing heated filaments that controlled electrical signals. These tubes were fragile, consumed significant power, and generated heat. A portable radio might need a dozen or more tubes, each a potential point of failure. Battery technology was equally limiting. Heavy lead-acid batteries provided power but added enormous weight. A portable radio with batteries might weigh 30–40 pounds, too heavy for infantry to carry along with weapons and ammunition. Germany entered the war with better radio technology than most opponents. The Wehrmacht had invested heavily in tactical communications, equipping units down to company level with radios. This gave German forces a significant coordination advantage in the early war years. German tank radios allowed armored units to coordinate complex maneuvers. While Allied tanks often relied on flag signals, German panzer commanders communicated by radio, coordinating attacks and responding rapidly to changing situations. The breakthrough came with compact, truly portable radios. The American SCR-300, introduced in 1940, was revolutionary. a radio that could be carried on a soldier's back. It weighed about 35 pounds, had a range of several miles, and could be operated by one person. This walkie-talkie changed infantry tactics. Now platoon and company commanders could coordinate movements, call for support, and report intelligence without sending runners through enemy fire. The SCR-300 became one of the most important pieces of equipment American forces carried. Being a radio operator was extraordinarily dangerous. The tall antenna made radio operators priority targets. Enemy soldiers were trained to identify and eliminate radio operators first. Cutting off a unit's communications would isolate and confuse them. Radio operators couldn't take cover like other soldiers. To transmit effectively, they needed to deploy antennas, often exposing themselves. The characteristic antenna sticking up from a foxhole or above a ridgeline drew enemy fire like a magnet. Japanese forces in the Pacific specifically trained snipers to target radio operators. The distinctive backpack radio and antenna made operators easy to identify. Casualty rates among radio operators were significantly higher than among regular infantry. Smart operators learned to lower antennas when not actively transmitting, or to use natural terrain features to hide them. Some units deployed dummy antennas to draw fire away from actual radio positions. The radio equipment itself was a burden. Carrying 35 pounds of radio, plus personal weapons, ammunition, and supplies meant radio operators were heavily loaded. They couldn't move as quickly or fight as effectively as other soldiers. Yet radios were so valuable that units would fight to protect their radio operators. A unit that lost its radio was isolated, unable to call for artillery support, reinforcements, or medical evacuation. Protecting the radio operator became a priority. When radio equipment was damaged by enemy fire, rough handling, or environmental conditions, units were crippled. Repairing field radios required specialized knowledge and spare parts that weren't always available on the front lines. Some radio operators became expert field technicians, keeping damaged radios functioning through improvisation and determination. Others carried spare tubes, batteries, and components, adding even more weight to their already heavy load. The German blitzkrieg tactics of 1940 demonstrated radio's revolutionary impact. German armored and air forces coordinated their attacks through radio communications with unprecedented effectiveness. Tank commanders could communicate with each other and with higher headquarters in real time. When a unit encountered resistance, tanks could quickly concentrate forces at the critical point. When opportunities appeared, they could exploit them immediately without waiting for written orders. Radio coordination between ground forces and aircraft was devastating. German ground controllers could call in Stuka dive bombers within minutes. The aircraft would arrive, receive targeting information by radio, and strike with precision that terrorized Allied forces. This level of coordination was impossible without reliable radios. Previous wars had seen aircraft and ground forces operating independently, rarely coordinating. Radio allowed them to function as a unified force. French forces, by contrast, had fewer radios and less training in radio coordination. French commanders often relied on telephone lines and motorcycle couriers. When German tanks cut those lines and outpaced the couriers, French units became isolated and confused. The communication advantage was as important as Germany's tank and aircraft superiority. Even when French forces had superior positions or numbers, they couldn't coordinate, pushed effectively enough to counter German maneuvers. The North Africa campaign became a testing ground for radio tactics. The open desert terrain was ideal for radio communications, few obstacles to block signals, and the need for long-range coordination in a fluid, mobile campaign. British forces learned hard lessons about radio security. German radio intercept units monitored British transmissions, gaining intelligence about unit positions and planned movements. This led to the development of better encryption and radio discipline. The Pacific Theatre presented unique challenges for radio communications. Dense jungle vegetation absorbed radio signals, reducing effective range dramatically. Mountains and hills blocked transmissions. Heavy rain damaged equipment and created static that made communications difficult. A radio that worked perfectly over 5 miles in open terrain might manage only a few hundred meters in thick jungle. This forced units to operate closer together or relay messages through intermediate stations. Marines established radio relay stations on high ground to extend communications range. These stations, often manned by just a few soldiers, retransmitted messages between units separated by terrain. The relay operators had dangerous jobs, isolated positions that attracted enemy attention. Some relay stations operated for weeks, maintaining critical communications links during extended battles. Others were overrun quickly, cutting off entire battalions from headquarters. Tropical humidity destroyed radios. Moisture corroded circuits, shorted connections, and made batteries fail. Engineers developed waterproofing techniques, but maintaining radio equipment in the Pacific required constant attention. Radio operators in the Pacific spent almost as much time maintaining their equipment as operating it. Daily cleaning, drying components, replacing corroded connections, all necessary to keep radios functioning in hostile conditions. Japanese forces operated sophisticated radio intercept networks, monitoring American communications and gathering intelligence. This forced American units to maintain strict radio discipline, limiting transmissions, using code words, and changing frequencies regularly. The tension between needing to communicate and maintaining security was constant. Too much radio silence limited coordination. Too much radio traffic gave the enemy intelligence. Finding the balance required skill and experience. Radio transformed artillery from an area weapon into a precision tool. Forward observers with radios could watch artillery impacts and adjust fire in real-time, walking shells onto targets with devastating accuracy. Before radio, artillery adjustment required visual signals, telephone lines, or runners. Each method was slow and vulnerable. Radio allowed observers to direct fire from concealed positions, adjusting aim within seconds of each impact. The speed of radio fire missions saved countless lives. Infantry pinned down by enemy fire could call for artillery support within minutes. The shells would arrive before the enemy could relocate or reinforce. This responsiveness made artillery far more effective. Batteries could support multiple units, shifting fire rapidly between targets as commanders requested. The flexibility was impossible before radio communications. Close air support reached new levels of effectiveness. With radio coordination, ground controllers could guide fighter bombers onto targets, providing exact locations and describing enemy positions in real time. Pilots could communicate directly with ground forces, confirming targets before attacking and receiving immediate feedback on accuracy. This prevented friendly fire incidents and made air support far more precise. Tank infantry coordination improved dramatically with radios. Infantry could communicate with tank crews, directing fire onto targets the tank crews couldn't see. Tanks could warn infantry of threats and coordinate movements through dangerous terrain. In earlier conflicts, tanks and infantry often couldn't coordinate effectively, leading to confusion and friendly fire. Radio solved this problem, allowing combined arms tactics that multiplied the effectiveness of both forces. The Normandy invasion required radio coordination on an unprecedented scale. Thousands of ships, aircraft, and ground units had to synchronize their actions across miles of coastline. Radio made this possible. Naval gunfire support ships received targeting information from shore fire control parties via radio. Aircraft coordinated bombing runs through radio contact with ground controllers. Landing craft navigated through radio beacons and received real-time updates on beach conditions. Airborne units dropping behind enemy lines depended entirely on radio communications. Scattered across miles of French countryside, paratroopers used radios to regroup, coordinate attacks on objectives, and call for resupply drops. Many paratroopers lost their radios in the jump. Equipment was damaged, lost in marshes, or separated from operators. Units without radios had to operate independently, unable to coordinate with other forces. Beachmasters used radios to coordinate the controlled chaos of landing thousands of troops and tons of supplies. They directed landing craft to specific beaches, ordered ships to halt or proceed, and managed traffic flow on congested beaches. Without radio coordination, the beaches would have become hopelessly jammed. Radio allowed beachmasters to respond to changing conditions, shifting landings away from heavily defended areas, prioritizing critical supplies and evacuating wounded. Naval gunfire support required precise radio coordination. Shore fire control parties identified targets, calculated coordinates, and transmitted them to ships offshore. The ships would fire, and controllers would adjust aim based on impacts. This coordination allowed battleships and cruisers to provide artillery support miles inland, far beyond the range of field artillery. The naval guns suppressed enemy positions that would have made advances impossible. Radio's greatest weakness was that enemy forces could listen to every transmission. This forced the development of encryption systems and codes to protect sensitive information. The most famous solution was the Navajo code talkers. Marines who transmitted messages in the Navajo language which Japanese codebreakers couldn't understand. The code talkers provided completely secure communications throughout the Pacific campaign. Mechanical encryption devices like the American Cigaba or British Typex scrambled radio messages before transmission. These electromechanical cipher machines were complex, heavy, and required trained operators, but they provided secure communications for strategic-level messages. However, tactical units rarely had access to cipher machines. They relied on code words, brevity codes, and radio discipline to maintain some security while still communicating effectively. Soviet forces initially lagged behind Germany in radio technology and training. Many Soviet units lacked radios entirely, relying on visual signals and runners. This contributed to devastating losses in 1941. German radio intercept units monitored Soviet communications, gaining valuable intelligence. Some Soviet commanders transmitted in clear language, discussing plans and positions that German forces could immediately exploit. As the war progressed, Soviet radio capabilities improved. Mass production of radios equipped more units. Training improved radio discipline. By 1943–44, Soviet forces used radio as effectively as their enemies. The Battle of Kursk demonstrated improved Soviet radio coordination. Artillery and tank units coordinated their defenses through radio networks. Air support responded quickly to ground requests. The improved communications contributed to the German offensive's failure. Soviet partisan forces operating behind German lines relied heavily on radios to coordinate operations and receive intelligence from Moscow. These long-range radios, often hand-cranked to generate power, maintained contact across hundreds of miles. Radio technology improved rapidly throughout the conflict. Early war radios were bulky and unreliable. By 1945, radios were smaller, more reliable, and had better range. The development of more efficient tubes reduced power consumption. Better batteries lasted longer and weighed less. Improved circuit designs increased range and clarity while reducing size. Frequency hopping techniques developed late in the war made radio intercept more difficult. Transmitters would rapidly change frequencies according to predetermined patterns, making enemy monitoring nearly impossible. Very high-frequency VHF radios offered clearer communications and were harder to intercept than earlier low-frequency systems. VHF became standard for tactical communications, though it required line-of-sight transmission. Miniaturization efforts produced truly portable radios. The handheld SCR 536, nicknamed Handy Talkie, weighed just 5 pounds and allowed short-range voice communication. It revolutionized small unit coordination. Vehicle-mounted radios became standard in tanks, jeeps, and trucks. These radios had better range and power than man-portable units, creating communication backbones for mobile operations. Radio fundamentally changed military tactics. Commanders could now employ flexible, responsive tactics instead of rigid, pre-planned operations. Mobile warfare became practical. Units could advance rapidly while maintaining communication with headquarters. Commanders could respond to opportunities or threats in minutes rather than hours. Combined arms coordination, infantry, armor, artillery, and air forces working together reached new levels of effectiveness. Radio allowed these different forces to coordinate their actions in real time. Decentralized command became possible. Lower-level commanders could make decisions and receive immediate guidance from superiors without waiting for written orders. This increased tactical flexibility enormously. Radio also enabled new defensive tactics. Defenders could call for artillery or reinforcements the moment they spotted enemy movements. Reserve forces could respond quickly to threats at critical points. The speed of communication compressed decision-making cycles. Commanders who could observe, decide, and act faster than their enemies gained decisive advantages. Radio was the technology that enabled this speed. The radio revolution that began during the conflict continues today. Modern military communications are the direct descendants of those first battlefield radios. Every advance in military communications, satellite communications, digital networks, encrypted data links, builds on the foundation established by field radios. The principle remains the same: connecting commanders with their forces in real time. Modern soldiers carry radios that would astound operators from the 1940s. Digital encryption, satellite links, GPS integration, and data transmission capabilities were science fiction then, but a standard today. Yet the fundamental challenges remain. Communications must be secure but functional. Equipment must be reliable in harsh conditions. Operators must be trained and disciplined. The technology has changed, the requirements haven't. The field radio's impact extended beyond the military. Post-war development of portable radio technology led directly to civilian innovations: walkie-talkies, mobile phones, and ultimately the smartphones we carry today. The skills developed by radio operators, clear communication under stress, technical troubleshooting, maintaining security, became valuable in civilian careers. Many radio operators entered telecommunications careers after the war, bringing military experience to commercial applications. Perhaps the most important legacy is the understanding that communication is as important as firepower. Armies that can coordinate effectively will defeat larger forces that cannot. This lesson, learned through field radios, remains central to military doctrine. The field radios that changed modern warfare were more than just technology. They were force multipliers that transformed how armies fought, how commanders led, and how battles were won. They connected the modern battlefield in ways that were revolutionary then and are taken for granted now. Today, when we make a phone call or send a text message, we're using technology that descended directly from those bulky, temperamental radios carried into combat by soldiers who understood that staying connected could mean the difference between victory and defeat, between life and death. The revolution they started continues. The battlefield remains connected, communications remain critical, and the descendants of those first field radios remain essential to military operations worldwide.